signals may be, we have one-dimensional signal, two-dimensional signal, three-dimensional signals, etc. A one-dimensional signal is a function of one variable. For example, speech signal, AC power supply signal, ECG signals, variation of room temperature, etc. are examples of one-dimensional signal. So it depends only on one variable. And if we have two-dimensional signal, the signal depends on two variables. That means output depends on two variables. And for three-dimensional signal, we can represent by f of x, y, z. That is, output depends on three variables. So this 2 and 3, if the dimension is more than 1, the signal is called multi-dimensional signal. Dimensional signal. 2D signal, example is image signal. X-rays, sonogram, etc. are the examples of two-dimensional signals. For a three-dimensional signal, we depends on three variables. For example, is video, then EEG signal. Basically, a signal is a function of one or more variables which will convey some information. Classification. So classified into continuous time signal and discrete time signal. A continuous time signal is represented by x of t, or discrete time signal is represented by x of n or x of nt. This is x of t against t. Amplitude of signal is a continuous function of time. That means signal is defined or known for all t. On the other hand, discrete time signal is represented by x of n or x of nt. This signal is defined or known only at discrete instance of time. Only at discrete instant of time. Right. Now we can represent a discrete time signal as a time sequence. Let's 0, 1t, 2t, 3t, and so on. This minus t, minus 2t, minus 3t, etc. Okay. This line or this dot will indicate the strength of the signal where T is the sampling period. X of n or x of nt is obtained or deriving from a continuous time signal. By the process of sampling. If the sampling period T is constant, then it is called uniform sampling. The value of discrete time signal x of n in between two discrete instants, let n minus 1t and nt. For example, it's n minus 1t and nt. Suppose the value of the signal at n minus 1t may this and nt may be this. So what is the value of signal in between n minus 1 and nt? It may or may not be 0, but it is not known, that means unknown or not defined. So we can't say it is 0, since if the value of the signal, original continuous time signal, in between this instant is 0, then the value is 0. Otherwise we can't tell this is 0. That is not defined. So I have a continuous time signal x of t. Let it is represented by this figure. Okay, let me represent this by the signal by in this form, right? Then okay, let this be the continuous time signal. And when it is passing through a sampler is represented by a switch. This is a sampler. Now the output of the sampler is the discrete time sequence, either xn or xnt. For uniform sample, x of nt can be represented by a number sequence for a time, that is x of n. So here we will extract the output. So the sampler will close at time 0, t, 2t, 3t, etc. or to here minus t, minus 2t, and so on. So the value of the signal is known at this instance. The value of the signal or the strength of the signal at n is equal to 0 is denoted by x of 0. At x is equal to t, it is given by x of t, or a number sequence. For a uniform sampling, it can be denoted by x of 1. The value of the signal at t is equal to 2t, that is indicated by x of 2t or a number sequence x of 2. Then here x of 3t or x of 3. This is indicated by x of minus t or x of minus 1 for uniform sampling. This is x of minus 2t or x of minus 2. The value of x of n, that is, will indicate the strength of the signal So what is the value of the signal in between x of 0 and x of t? Now I am taking in general x of 0 or at an instant n minus 1, that is n minus 1t to nt. That is the distance between two consequent time, n minus 1t to nt, either t to 2t or 3 to 4t, etc. So in between this duration, we can't say the value is 0. The value is 0. So don't say value 0. It may or may not be 0. May or may not be 0. If the original value of the continuous time signal is 0, then it is 0. Otherwise, it is not 0. But we don't know what is the value. Here, suppose t is the sampling period. Then the sampler closes at 0, t, 2t, 3t. And in between this time duration, 0 to t, t to 2t, 2t to 3t, etc., the sampler remains open. When the sampler is open, no signal will pass through the sampler, so that we didn't get any output. When it is closed, so signal is passing through, and we can extract the output. Okay. Suppose at t equal to 0, suppose this is the t, let this t, then 2t, let this be like this. Let this is 2t, 3t, and 4t, minus t, 0, and minus 2t, the signal. So when this signal is processing, the sampler switch is closes at the instant minus 2t, then minus t, 0, t, 2t, 3t, 4t, etc. In between the instant, this will open. This will open means no signal can pass through the sampler. No signal can pass. So we can't get any output. Okay. So what is the output corresponding to the signal? Suppose this signal is sampling at a sampling rate of t, then 0, t, 2t, 3t, 4t, etc. And the value of the signal at t is equal to 0 is 0. So the strength of the signal is 0. At t equal to 1, this is the value of the signal. Value of the signal, it is indicated by line with a dot. This indicates the value or amplitude of the continuous time signal, corresponding continuous time signal. At 2t, the value of the signal is this. So that is indicated by a line like this. At t is equal to 3t, this is the strength of the signal. The value of the continuous time signal is this point. So that is represented by this point. At t is equal to 4t, this is the strength of signal. And again, for t is equal to minus t, this is the value. And minus 2t, this is the value of the signal. So this is the representation of a discrete time signal when passing through the sampler. So at the t equal to 0, this is closed. So signal pass. When t is slightly greater than 0, that is t is slightly greater than 0 means t is equal to 0 plus. This will open. This will open means no signal can pass through the switch. The switch is open. So we can't get any output in between 0 and t. At the time instant t is equal to t, again this will close. So the signal will pass. At that instant, the value of signal is this. This is the value of the continuous time signal. So we get an impulse having the strength is equal to the corresponding continuous time signal. Then in between 0 to t, the original signal has, the continuous time signal has value, continuous amplitude. But that amplitude can't pass through the sampler. So we can't say this is 0. The original value is from varying from 0 to t along this line. But we can't get the value. So we simply but we can't say that is 0. At t equal to 0 instant, the original value of the signal is 0. So it is 0. So we can say the value of the signal is 0 at t is equal to 0 and so on. Sampler. Or actually, the concept of sampler. Concept of sampler. We know that the discrete time sequence dts, that is represented by x of n, we are getting the sequence from x of t, from x of t, we are getting x of n. Actually, and we are representing x of n as time sequence, that is x of 0, x of 1, x of 2, goes on, and here x of minus 1, x of minus 2, etc. Minus 2. That's a time sequence. Now, what happens? In between, consider time 0, 1, 2, 3, minus 1, minus 2, etc. So the value of the signal, the value of the signal is known at n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, n minus 1, minus 2, and so on. So for these integers, we know the value of the signal, that is x of 0, x of 1, x of 2, etc. In between 0 and 1, and 1 to 2, 2 to 3, 0 to minus 1, minus 1 to minus 2, etc., the signal is unknown. The signal is not defined. The signal is defined only at discrete instant of time. Right. Now, consider, and we have the sampler. Inside, the input to the sampler is continuous time signal, and the sampler is denoted by like this. And we are extracting the output from here. Right, output from here. And the sampler closed at this instant, 1, 2, 3, 0, minus 1, minus 2, etc. When the sampler closed, the signal will pass through and the circuit is complete. Or for the time in between 0 and 1, 1 to 2, 2 to 3, etc., the sampler remains open and we didn't get any output. Right, we didn't get any output. Now consider this point 2. Randomly taking a point 2. This is time. Our time is 2, in between 2 and 3. I am considering this interval in between 2 and 3. Now, when our time t is less than 3 minus and 2 plus less than t minus, during this time interval 2 plus less than t less than 3 minus, what happens to the sampler? Sampler is open. Sampler is in open position. That is, this is the position of the sampler. It is in open position. Then what about the output? The output is, we get no output. No output. We can't say 0 output because we don't know about the output. So output is not defined. In between this, that is, output is undefined in this duration of time. Now what does 2 plus indicate? 2 plus indicate means 2 plus means 2 plus. 2 plus implies limit t tends to 2 plus, that is approaching from 2 in the right side. So very close to 2. From approaching from right hand side and 3 minus, this 3 minus, that is implies limit t tends to 3 minus, that is approaching from this side, that is very close to 3 when approaching when approaching from left hand side of 3, right? So this time, so in between 2 plus less than t less than 3 minus, we know that the sampler remain open and we didn't get any output. Now for the duration, so this is the indication of 2 plus and 3 minus, right? Now for the time duration, this means 2 plus means limit t or n. Here t tends to 2 plus and 3 minus is limit t tends to 3 minus. Time interval 3 minus less than or equal to t less than or equal to 3 plus. So approaching a point very close to 3, approaching from left hand side, that is a 3 minus, and 3 plus is approaching from right hand side of 3, a point very close to 3. During this time the sampler gets closed. Now this is the position of the sampler which is closed, and the signal will pass through it and you will get the output from here. Now we have output. Now from 3 plus less than t less than 4 minus, that is 3 plus during this time interval, what happens to sampler? Sampler remains open, so there is no output. So during this time duration, that is the in between 3 minus and 3 plus, we get output, right? So this is 3 minus to 3 plus. This implies an impulse. Strength of this impulse, strength or amplitude of this impulse is equal to the amplitude of corresponding continuous time signal. In general, we can say during this is n minus 1. Let this is the nth instant. So the value of the signal corresponding to is x of n minus 1, and for it is x of n. Right. Now n minus 1. Right. N minus 1. I'm putting n minus 1 t and nt. Right. So this is n minus 1 t, x of n minus 1 t and x of nt. Now the time n minus 1, that is during the, we are considering the time duration in this time interval, that is n minus 1 t minus t plus, approaching from this side, left t, approaching from the right side, less than t less than n t minus. So the right of n minus 1 and the left of nt. The sampler, what happens? Sampler remains open, so we have no output. For the time duration between nt minus and nt plus, that is here 3 minus to 3 plus. So similarly nt minus less than or equal to t less than or equal to nt plus. What happens? Sampler closed. So we can get the output here. Signal will flow through, so we will get output. And for the instant nt plus 1, less than t less than n plus 1 t minus the sampler remains open. So we get no output. So this is the basic operation of sampler. Even and odd signals. Even and odd signals. Now consider a time signal x of t. Right. Then this x of t is said to be even if x of minus t is equal to x of t, or in discrete domain x of n is said to be even if x of minus n is equal to x of n. Right. Now consider the signal x of minus 1. So when n is equal to 0, what happens? This implies x of 0 minus 0, f of minus 0 is x of 0. This is equal to x of 0. That means minus 0 is 0. X of 0 is equal to x of 0. Right. Now n is equal to 1. What has happened? That is x of minus 1. That is equal to x of 1. N is equal to 2. X of minus 2 is equal to x of 2. N is equal to 3. X of minus 3 is equal to x of 3. Let's go on. That means this implies the signal should be symmetric with respect to vertical axis, that is y axis. Then only this condition is satisfied. So we can draw an even signal. So this is suppose this is a value of x of 0, 0, 1, 2, 3, 4, minus 1, minus 2. Okay. Then suppose this is the value of the signal x of 1. This is x of 0, x of 1. Then if the signal is even, then x of minus 1 is same as x of 1. So we can represent x of minus 1. Right. Suppose this is our x of 2. X of 2. Then x of minus 2 is the replica of this. This is x of 2 and x of minus 2. Both are same. Then suppose this is our x of 3. Then x of minus 3 is a replica of this x of minus 3. So the signal will be symmetric with respect to y-axis. This is our y-axis and against n. Right. Then similarly x of t. We know what is x of t. X of t minus t is equal to x of t. Example, this is our time and x of t, RHS, right hand side. So the left hand side is a replica of the right hand side. So this should be replica. So in between this interval, the signal is like, and from here and so on, for an even signal. Right. So if you fold the signal, they will overlap. Consider an odd signal. Okay. And for odd signal x of t, we have the property, let the signal be x of t. Then what is the property of an odd signal? For an odd signal, x of minus t, this is equal to minus of x of t. This implies x of minus t, I am taking this to here, plus x of t, that is equal to 0. Right. Then when t is equal to 0, what happens? X of minus 0 plus x of 0 is equal to 0. X of minus 0 is same as x of 0. That is 2 times x of 0 is equal to 0, or x of 0 is equal to 0. So an odd signal will always passes through the origin. Passes through origin. Right. Discrete signal x of minus n is equal to minus of x of n if the signal is odd. That implies x of minus n plus x of n, this is equal to 0. Right. This is for an odd signal. Now n is equal to 0. What happens? This means x of 0 plus x of 0 is equal to 0. This implies 2 times x of 0 is equal to 0, or x of 0 is equal to again 0. This implies signal should pass through the origin. Pass through the origin. Now n is equal to 1. This implies x of minus 1 plus x of 1 is equal to 0. So if I am drawing a figure, right, see, this is x of n against n, 1, 2, 3, minus 1, minus 2, minus 3, right. So at 0 is 0, right. Then x of minus 1 plus x of 1 should be 0. That means, suppose this is x of 1, let it be 1 is equal to 1. So x of 1, that means plus 1. So x of minus 1 should be minus 1. Then only the sum is equal to 0. So the x of minus 1 will comes like this. This is equal to x of minus 1, that is equal to minus 1. Right. Now n is equal to 2. This implies x of minus 2 plus x of 2, that is equal to 0. That means I am drawing, let this be x of 2, the value of the signal. Let this is equal to x of 2. This dot indicate the strength of the signal. This is equal to let 2. Then to satisfy this condition, x of minus 2 should be x of minus 2 should be minus 2. Then minus 2 plus 2 is equal to 0. Now suppose this is the value of signal at 3. Then x is equal to 3, x of 3. Then x of minus 3 will comes like this. This implies an odd signal is anti-symmetric with respect to origin, and it will always passes through origin. Case of a continuous time signal, suppose the signal is, then this signal is odd. This signal is odd. That means x of minus t plus x of t is equal to 0. Now consider an area between this duration. So for here, what should be the value? The signal should be anti-symmetric with respect to the origin. So this portion I can draw like this. So during this area interval, the area of this portion plus this portion is equal to 0. Okay. Now for this duration, during this duration of time. Let this is 0, t by 2, t, and so on. This is minus t by 2, t. So during t by 2 to t, this is the graph. So from minus t by 2 to t, the graph should be like this. Like this. So if we are considering a time duration of this much time duration. So area of this area of this plus this is equal to 0. Area of this plus this is equal to 0. So it should satisfy this condition. Right. That means it always passing through the origin and anti-symmetric with respect to the origin. Complex values signal. Complex valued signal. X of t. A complex valued signal x of t can be represented by a of t plus j into b of t. Signal, this complex value signal is said to be conjugate symmetry. Conjugate symmetry. If x of minus t is equal to x conjugate of t. If this condition is satisfied, then the signal x of t is said to be conjugate symmetry. That causes the term conjugate symmetry. Now, what is x conjugate t? X conjugate t is equal to a of t minus j into b of t. Right. Now, x of minus t, that is equal to a of minus t plus j into b of minus t. For the condition of the conjugate symmetry is x of minus t. That means this is equal to x of minus t is equal to, that implies a of minus t plus j into b of minus t should be equal to x conjugate t. X conjugate t, that is equal to a of t minus j into b of t. This implies a of minus t plus j into b of minus t, that is equal to a of t minus j into b of t. Now comparing the real and imaginary part. This is a complex number or a complex signal. So this equal means a of minus t should be equal to a of t. And b of minus t is equal to minus b of t. This implies a of minus t is equal to a of t. That means a of t is an even signal. That is, real part of the signal x of t is an even signal. This implies real part of x of t is an even signal. Now, equate the imaginary part. Here the imaginary part is b minus t, that is equal to, in RHS, this is minus b of t. B of minus t is equal to minus b of t implies b of t is an odd signal. That implies x of t is said to be complex. That implies x of t is said to be conjugate symmetric if b of minus t is equal to minus b of t. That is not. A complex value signal, a complex valued signal x of t, that is x of t is a of t plus jb of t, is said to be conjugate symmetry. If the condition number 1 is the real part of the signal is an even signal, that means real part of x of t should be an even signal, and imaginary part of x of t, that is b of t, imaginary part of x of t should be an odd signal. So this is the condition for a signal to be conjugate symmetric. Now, example of an even signal, even signals, that is x of t is equal to cos omega t. Then this is a signal. Then another example is a square signal. Next example is a sawtooth signal. These all are even signal. For an odd signal, example is sin t or sin omega t. And a square signal. Suppose a square signal like this. Then here, this square is an odd signal. This is our x of t against time. Symmetric with respect to vertical axis. Here, this signal passing through origin, and anti-symmetric with respect to origin. So an odd signal. Nano signal. Nano means neither even nor odd. Example, x of t is equal to e raised to t sin 2t. This is a nano signal. Now, any signal can be represented as a sum of even signal and odd signal. So, note, any signal x of t or x of n can be represented as the sum of an even signal and a odd signal. That is sum of an even signal and an odd signal. For example, that means x of t, suppose x of t is a nano signal, then this can be represented x of et plus x suffix ot. This is a even portion, even part or even portion, and this is the odd portion of the signal, where x of even portion of the signal, x of et is equal to x of t plus x of minus t by 2, and odd portion of the signal is equal to x of t minus x of minus t divided by 2. In the case of a discrete time signal, x of even n, that is equal to x of n plus x of minus n divided by 2, and odd portion is equal to x of n minus x of minus n divided by 2. Question. X of t is equal to e raised to minus 2t sin t. Find, this is find even and odd component of the signal. This is a nano signal, that means neither even nor odd. So x of even portion of t, that is even component, is equal to x of t plus x of minus t by 2. What is x of t? X of t is equal to e raised to minus 2t sin t plus x of minus t, replace t by minus t. That is e raised to minus 2 minus t into sin of minus t. That is equal to e raised to minus 2t sin t. Sin of minus t is equal to minus sin t. That means minus e raised to, this minus 2 into minus t. That is equal to 2t into sin t. Sin t is common, that can be taken. Whole divided by 2. This whole divided by 2. That means sin t is taken outside. So we get sin t is into e raised to minus 2t minus e raised to 2t divided by 2. Now sin ht, that is hyperbolic sinusoidal, that is equal to e raised to 2t minus e raised to minus 2t by 2. Hyperbolic cosine is equal to e raised to 2t plus e raised to minus 2t by 2. So we can write this is equal to minus, this e raised to minus 2t first time. So minus is taken outside. So this become minus sin t into hyperbolic sinusoidal. Sin t into sin ht. That is the even component of this signal. Odd component, odd portion, that is x of t is equal to x of t minus x of minus t divided by 2. That is x of t, e raised to minus 2t sin t minus e raised to minus of minus 2t. That is e raised to 2t into sin of minus t. Again, this minus is sin of minus t is equal to sin t. So this become e raised to minus 2t sin t, this divided by 2, minus of minus plus e raised to 2t into sin t divided by 2. That is equal to sin t is taken common out. Sin t into e raised to minus 2t plus e raised to 2t divided by 2. Or this is a hyperbolic cosine. That is sin t into cos ht. This is the odd component of the signal. This is ordinary sine or cosine. That is odd, and hyperbolic sine or cosine. This is sine or cosine. That is, this is sine theta or cos theta. Here sine h theta or cos h theta. Ordinary trigonometry, sine square theta plus cos square theta is equal to 1. This will form a unit circle. That is a circle having radius 1. This is our unit circle. So analysis in ordinary trigonometry is performed on a unit circle. But sin ht, that is hyperbolic sine and hyperbolic cosine, cos ht forms the right half of the equilateral triangle. This means ordinary trigonometric form a circle, but hyperbolic function of sine and cosine form the right half of an equilateral triangle. That's the difference between ordinary trigonometry and hyperbolic trigonometric. X of t is equal to t sin t. Again, this is a nano signal. This implies a nano, neither even nor odd signal. We can draw the signal as this. We can draw x of the signal as this is t, right, t, and this is signal t into sin t, is t, right, and this form a nano signal. So we can write x of t is equal to an odd component plus an even component. Here odd component is equal to x of t minus x of minus t by 2. That means t into sin t minus x of minus t. T is replaced by minus t. That means minus t into sin of minus t by 2. That is t sin t. Minus is minus t. Sin of minus t is minus sin t. Minus sin t. This minus and minus get cancel. This become t sin t minus t sin t. This is equal to 0. Even portion of the signal is equal to t sin t plus minus t into sin of minus t divided by 2. That is t sin t minus t, this minus is taken outside, so that become plus t sin t by 2. T sin t by 2. 2 and 2 get cancelled, that is equal to t sin t. That is odd portion of the signal is equal to 0 and even portion of the signal is equal to t sin t. But this is a nano signal. And odd component of the signal x of t is equal to e raised to j t. E raised to j t. What is e raised to j t? E raised to j t is equal to cos t plus j sin t. Now, choice is given. A is cos t comma j sin t. B is cos t comma minus j sin t. And option C is sin t comma j cos t. And option number D is minus cos t comma j sin t. These are the 4 options given. Now, x of minus t is equal to e raised to minus jt. So, even portion of t is equal to e raised to jt plus x of minus t, that is e raised to minus jt by 2. That is equal to, what is e raised to minus jt? E raised to minus jt is equal to cos t minus j sin t. So, e raised to jt plus e raised to minus jt is equal to 2 cos t. This implies cos t is equal to e raised to jt plus e raised to minus jt divided by 2. Similarly, sin t is equal to e raised to jt minus e raised to minus jt divided by 2j. Right. So this is equal to, what do we get? Cos t. And odd portion of t or odd component is equal to e raised to jt minus jt divided by 2. This is equal to e raised to jt minus e raised to minus jt by 2. I added, so a 2 j, I added a j here, so j is added. So the denominator is multiplied to j and numerator is also multiplied to j. This is equal to sin t. So into j, that is j sin t. So cos t and j sin t. So C is the answer. Even part of the signal x of n is equal to u of n plus u of minus n is, option is given, u of n minus u of minus n. Second option B is u of n plus u of minus n. Option C is u of minus n minus u of n, and option D is 2u of n. And we know even part x e of n, even part is equal to x of n plus x of minus n divided by 2. That is, x of n is u of n plus u of minus n, plus x of minus n is replaced by minus n. That become u of minus n plus u of minus, that is u of n divided by 2. That is equal to u of n and u of n get added, 2u of n plus u of minus n and u of minus n added, that is 2u of minus n divided by 2. 2 and 2 and 2 cancel. This is equal to u of n plus u of minus n. So the answer is B. So B is the